So at this point, what we know is that the derivative of an exponential function is the exponential function itself. Remember, that was the case where we're going natural log of e times e to the x, and natural log of e is 1. So this is, as we said before, this is a special function. And so we really have to remember this rule and be able to use this all the time. Derivative of e to the x is e to the x. So that's what we need to know and remember. Furthermore, then we can also use the chain rule to get further derivatives. So if it's e to the power of a times x, so it's not just e to the power of x, but some number times x, the derivative of that would be a times e to the ax. So there's another rule to use. Or in a more specific type of, or more specific, more general type of function, if it's e to the function of x, that would equal the derivative of the function times e to the function. Notice again, that function won't change, but we multiply it by the derivative of the function. So that's how we use the chain rule in relation to the exponential function and the derivatives of the exponential function. So keep reminding yourselves as well that it's what we're talking about is the derivative function. It's the rate of change or the gradient function. So the gradient function was the same, or it's in proportion. So let's have a look at the derivatives of these functions here. So notice here it's e to the power of 4x. So e to the power of 4x would stay the same, and we multiply it by the derivative of 4x, which is 4. 2e to the x on 2, that would become really the 2 times e to the x on 2, and that's multiplied by the derivative of x on 2, which is a half, and the 2 cancels with the half to give us e to the x on 2. This one, the 4 e to the 3x, the e to the 3x stays the same. The 3 will multiply by that 4 to give you 12. And the minus 2x, e to the minus 2x stays the same. Minus 2 multiplies by minus 1 to give us the plus 2. So we're keeping the numbers in front. So d, derivative of 4x is 4, e to the 4x. Derivative of e to the 3x would be 3 e to the 3x. So notice multiplying by the derivative of that one. Now this one, 2 e to the minus 3x becomes 6, because the derivative of 3x is 3 times the 2, and this would be minus e to the minus 1. Sorry, it won't be. Oh, I've fooled myself. I wondered why I was doing that, and I've made an error there, because it won't be, because if we look at that, e to the minus 1 is a constant. So the derivative of e to the minus 1 is 0, because a derivative of a constant is 0. So e to the 3.2x becomes 3.2 times e to the 3.2x. E to the minus 1.x is 1.6, e to the 1.6x. And 3 to the power of x, well, that would say the same. Derivative of e to the x is e to the x. Derivative of e to the minus x is minus e to the x. So notice the sign has just changed there. So we've got to be really careful and apply those rules. So remember, we're applying the rule y is equal to e to the function of x. Then the derivative of that would be the derivative of the function times e to the function. So notice that function there won't stay like it normally does in the chain rule. The function doesn't change. We multiply by the derivative of the function times the e to the fx.